And it's almost recording. There it is. Okay. I hope you guys are good and you survived me talking a long time last time. Any questions on what we covered?
I have a question about my IK system.
Okay.
So when you create your IK system, is it okay? So if I'm remembering correctly, it's not okay for your base joint to have any rotation values after you create. So, sorry, I'm doing a bad job of explaining this. So I have no rotation values when I start the IK system.
Correct.
But then when I do the pole vector constraint, my base joint rotates. It's like negative 0.005 in the x-axis, I think.
For the elbow?
Just for the base joint. The elbow is still at 0, like everything, except for the x.
And are you talking, you're saying rotation. Are you talking rotation or are you talking joint orient?
Rotation.
Okay. Did those values pop on after you added the IK system, or were they already there?
Yeah, after I added the IK system. And I've gone through and I've like remade the IK system like 10 times and like tried to reset everything to 0 and made sure my orients were correct. I'm just not sure what's going on with my system.
And that's a really, really, really small value?
Yeah, it's seriously, I think it's negative 0.005.
Yeah. I don't know why the IK systems do that. I really don't. If you have verified that your joints are set up correctly and it adds that little bit to it, then, oh, you know what it is? You said it's in the X?
I think so. Let me double check. Yeah, it's my X rotation.
So that's your twist, right? So the IK system, it does, I don't know why, but it does add a little bit. Sometimes it adds like minuscule values. It must help it somehow in knowing what goes where. I really don't know why it does it. That twist axis may indicate that your pole vector control is not perfectly in alignment with that plane. So you might check and ensure that your orientation on that pole vector group, if you're positive the joints are set correctly, then you can check and make sure that the group for the pole vector control is also set correctly, and that your offset group, you haven't gone anywhere in the, you can go back in Z, and you can go with, am I thinking right? No, Y and X and Y, you can move in that plane of X and Y, but you can't move in Z. So if you verified that all of that is true and it still gives you that little teeny weeny value, I'd say that's probably not enough that you have to worry about it. It's a pretty small value. In a perfect world, nothing would show up. So I guess if you'd like me to look at the joints a little bit later, I'd be happy to do that and just verify with you and look at that control. But that's probably the best answer I can give to you.
Yeah, I mean, nothing's quote unquote broken yet. So
yeah.
I'll probably just roll with it until it breaks.
Yeah, I would go with it. Today we're gonna, go over the blending between the IK and the FK. And if you can blend between the two and you don't see anything shift, then it's good enough. Good enough. That's the only problem, is when you have shifting when we go from one system to the other. But that value is so small, I don't think you'll see anything. So, okay, any other questions? Okay. Well, then let's get this guy tied up. I think we could have our arcade done today and constrain all of our proxy geo and have this character actually moving around. Okay. So let's just talk principles real quick. We kind of went over this idea last time where we're just combining. It was in this class, wasn't it? Yeah. We're combining the IK system and the FK system together onto another duplicate joint chain that is we're calling the RK system, or receiving kinematic system. We're doing that all via parent. I'll do parent and scale constraints. So parent and scale constraint. Okay, that's what all of these represent. Same thing over here. So basically, any transformation on either of these joint systems is going to be constrained to this RK joint. So it will take on those same transformation values. When we create a constraint, a constraint has a target, right? That's the object, that's the constrainer, that's kind of like the parent object. So we'll have a target. And each of our targets have a weight. If you remember, the first one is called weight 0. It's just like a list, a zero-based list or array. And we have a value here, right? By default, it's set to 1 or 100%, which means the value of that target will constrain, right? Control 100% of the object that is being constrained. When we add multiple objects, so we'll call this target 1, we can call this target 2. This we'll call it weight 1. Maybe I'll make these look like 1s so we know what it is. Okay, by default, when you have multiple targets, both of them will be created with a weight of 1. So just so we know what this is the weight. Which also means that this has 100% influence on the constrained object. And when Maya has multiple objects that are both constraining something at the exact same percentage, then it basically just splits the difference. So in reality, both of these have 50% control over the joint. And we saw that again last time. We visualized that here in the leg, right? If you remember the RK joints here, we created all these constraints. So RK1 has the leg 3 FK joint and the IK joint were both set as targets. They both have a weight of 1. So that leg, that joint, and the other joints in it with their respective constraints are moving 50% with the joint that I'm rotating back right now. So if I were to take my FK system and do the same thing, right, you'd see 50% of the influence from the FK joints as well. Okay, and that's the position and the rotation and the scale. But note, when I go like this, you see my RK joints are shrinking. All right, they get really small all of a sudden. Just note that all of this is doing is taking the midpoint between the joints that I, essentially the midpoint or half of the rotation. So you can see my knee right now is essentially it's right in between these two knee joints. Okay, so it had to shrink in order to pull back up here. But they both have this 50% pull on it. Okay, this joint's not directly in alignment, and that's because the parent rotated a little bit, but the same idea follows. This had to shrink in order to maintain kind of a 50% influence between the two. So this is something to note when we blend from one to the other, one system to the other. You want to get your legs matched up as closely as you can so that you don't see this weird deformation of the leg. Either that or you just switch it in a single frame so we don't see any transition at all. But anyway, the concept there really is that both of them have 50% influence when they're both set to a weight of 100%. So what we want to do here, if we were to change this now, instead of calling it target 1 and target 2, let's call one of them FK. We'll call one of them IK. And remember, we've got our little magic switch over here doing its magic. And our switch, we're going to have just as a float value. It's going to go somewhere between 0 and 1. So no influence, or like 0 or 100%, on, off. Okay. And I call this IK switch, but really I should be calling it our IK-FK switch because it's going to control both. Okay, so one system is on or the other system is on, or we're in the process of blending between the two. That's what this allows us to do. So value between 0 and 1. What we want to have this do is when, well, sorry, let's step back a minute. When we say 0, we're going to say IK is on. Okay. And when we say 1, we're going to say FK is on. And, you know, I don't know if we need to specify this or not, but that means our FK is off over here and that our IK is off over here. Okay, so one of us on, when one is on, the other is off. We're not going to have both active at the same time. Okay, and you guys might remember some of this nonsense. We have to start digging into the connection editor or the node editor and start creating some utility nodes that allow us to alter our values a little bit. Okay, but that's our concept here. Okay, so 0, I said this last semester too, but I write this order very specifically as IK, FK. I never do FK, IK. I always just keep it IK, FK. And the concept is I just kind of look at it left to right, and I look at these values left to right. This always goes IK to FK. This always goes 0 to 1. And so I kind of match the two of these up. Okay. IK is on when this value is set to 0. Okay. FK system is on when this value is set to 1. We're going to have to, like I said, create some utility nodes to translate the numbers to do what I want them to do. But that's the idea there. When IK is set to 0, this is what happens. When the IK-FK switch is set to 0, that is what happens. When it's set to 1, then this is what happens. Okay. So I noticed this was confusing for a lot of people, and maybe it's because the idea that 0 usually means off and 1 usually means on. And that is going to be true when we come over here to the weights. But over on this side, just think of it less as on and off and more as it's just a toggle switch. We're saying we want this to be on or we want this to be on. Okay. So well, let's talk about how we do this. The FK system, what's nice about FK is when this switch is set to 1, then my weights should also be set to 1 because it's on. Okay. When my IK-FK switch is set to 0, the FK system should also be set to 0 because it's off. So there's a 1-to-1 ratio between the IK-FK switch and the weight value of my FK system. It just happens to line up that way. So that being the case, that allows me to create a connection. Let's do a connection using blue. I can do a connection directly from this switch into any of my FK weights. Okay, and that will turn them on or turn them off with the exact same values of the IK-FK switch. Okay, those match up perfectly. It's exactly what I want. Okay. The IK system, however, is inverted. when IK is set to 0, which normally means off, I want my IK system to be turned on, right? But when this is set to 1, which typically means on, I want my IK system to be off. So I've reversed my numbers. I've just inverted my numbers. And for that, we have to create a little utility node called a reverse node. It's going to take our IK, FK value in as an input, and it just does a little equation. It says 1 minus input. That's what this node does. And then we send that over to our IK system. So, you know, again, if we just do the math here, if our IK, FK switch is set to 0, we're going to feed that value into our reverse node. 1 minus 0 equals 1. So we've inverted the number, and then we can put that into our IK system, which will set the value here, our weight value, to 1. But we've got this direct connected, our FK system is direct connected to the switch. Remember that value is set to 0 still. So that's going to set our FK weight to 0, right? So this is set to 0 and this is set to 1. So they're inverted. That's what we want when our value on our IK, FK switch is set to 0. And then if we were to set this to 1, again, we're direct connected to the FK system. So if IK, FK switch is 1, then the FK weight is 1. We're going to send that same value here to our reverse node. 1 minus 1 is 0, right? Which is the value we want because IK system is off. That reverses it, brings 0 to my IK weight, and we've got those inverted values there as well. So FK is on while the IK is off. Okay? Any questions about that? Principally, how that's going to work?
I think I get it.
Okay. Speaking up, that helps. So, like I said, last time, if you remember, we went through all of the RK joints and we created our parent and scale constraints. So we already have our FK and our IK targets set up for each of those green joints. So the arm and the leg joints. Okay. Also, the last thing we did was create this transform control. And this is where we're going to put our IK, FK switches on this global level node, you know, at the top of our hierarchy that's never going to disappear. It's always going to be visible and accessible to us as animators. Okay, let me turn this off really quick. Okay, so we need to create those switches. So we need some custom attributes here on this control. So with the transform selected, we're going to go to channels, edit, add attribute. And we're going to create an individual channel for each limb, for each system that we've created, an IK, FK, and an RK system, okay? Don't do an overall, don't just do one IK, FK switch. Then that switches all of the limbs at once. I can't think of a reason why you would ever want that. You guys have animated some too, right? Oftentimes your legs will be in one while the arms are in the other, and flip back the other way. So we're going to call this left arm IK, FK. It's a float value. And I'm going to set the minimum to 0 and the maximum to 1. So it can't go below or above those values. My default set to 0, that's fine. And I'll click add so that this window stays up here and I can create the other attributes for the other limbs as well. So then we'll have right arm IK, FK. Same thing, I need to add a minimum and a maximum of 0 and 1. Go ahead, OK. I'm going to have left leg IK, FK. Minimum maximum value. And lastly, we'll do right leg IK, FK. And minimum maximum of 0 and 1. Then I can hit OK. So those are going to be our switches, right? That is this value right here. So to limit confusion, we're just going to work on one of these right now. We're just going to focus on the left arm. And we're going to bring up the node editor. So under Windows, find node editor. And I'm just going to drag that down here and attach it to my viewport here. All right. So I'm going to start by bringing this transform node into my node editor. So I have it selected right now. I can just click this little plus button with the dotted box around it. That'll bring that node in. It also brings its shape in. I don't need the shape. It's clutter. You can keep it there. You can not. It is a little clutter. I'll just select that and click the minus button here. Don't press delete or it will delete it. But the minus button will remove it from your node editor. Okay, I also need to go to my actual RK right arm. So let's find it here. Here are my 3 joints. So I'm going to bring in all of these constraints. Okay, these should look like this, where we have our FK and IK joints with their weights both set to 1. I'm just going to take all of these. I can click that plus button again. You can also middle click from the outliner if you have a selection and drag it directly into the viewport or the what is this thing called? The node editor, just so you know. I'm going to organize these just a little bit, just so the different associated parent and scale constraints are together. So here's joint 1. There's the parent and scale. Joint 2, parent and scale. And this is middle click. Your navigation is the same as in the viewport. Alt middle click, or even just plain old middle click, will pan around this node editor workspace. And so then there's the arm, parent, and scale constraint. Let's bring those a little bit closer here. Okay, so let's start first. Let's just take a peek at, hopefully you guys can see that and it's not too small. Let's maybe just line these up. In fact, sorry. Sometimes I get ahead of myself. Let's just move these other ones out of the way for a minute. Let's just focus on one of these constraints and that transform control. So if you remember, you can click the little capsule hamburger icon thing on the right of these icons, and it will expand to the different channels. You can also press 1, 2, 3, or 4. 1 collapses it all the way. 2, I can't remember what that does. Maybe it shows connected. I think that's what it does. It shows things that are currently connected, which nothing is connected, so that's why it's not showing anything. 3 shows, I think it shows all of the attributes, and 4, I can't remember what 4 does. It's all in here somewhere. Custom mode. I don't even know what custom mode means. Full mode will show all of your attributes. Okay, so I'm just going to press 3 for now. And the way this usually lists them is you'll see your transformations. You'll see a bunch of the attributes you don't normally mess with behind the scenes. These are things you see in your channel box. These are things you'll see in your attribute editor. And then down at the very bottom, you'll see your custom attributes. So if you remember, if I'm just focused on the IK-FK switch for the arm, my FK systems they have this one-to-one connection with the switch. So I can take my left arm IK-FK. Let's expand this parent constraint as well. I'll just select that and press 3. Now let's see if we can find my weights. So they're right here. Left arm FK joint, weight 0. That's the thing you should be looking for, that W0, W1, so you know you're looking at the actual target. So I want to connect directly to the FK joint, which is weight 0. So I'm going to drag from left arm, IK-FK. Right, the right side represents outputs, the left side represents inputs. I'm going to drag from this output directly into the input of the FK joint. If I look at my FK joint, or excuse me, the FK joint target weight attribute on the parent constraint, you'll see now that this yellow bar appears, indicating that you have made a direct connection to another attribute somewhere else. You can see that the value is set to 0. If I go to my transform control and look at the value on my left arm FK control or attribute, you can see that I also have a value of 0. If I bring this up to 1, I should expect to see the exact same thing when I click back on the parent constraint, and I do. So those two attributes are tied together. I'll just undo that. Okay. So with that in place, really it's the same logic that's going to follow for the rest of these. Okay. They all are going to have an FK weight, and I'm going to tie this switch directly into them. All of these constraints are part of the left arm. So there's 2 constraints for each joint, shoulder, elbow, and wrist. And I need to tie this same value, the same attribute to each one of the FK target weights. So I know some of you guys are really visual and you like this whole drag and drop thing here in the node editor, and that's fine. Maybe just I worked on it old school, so I don't often use this way. Let's do one more this way, and then I'll show you the other way I do it. So again, I'm dragging from left arm IK FK, and I'm going into the FK joint weight. Right now, I'm just leaving the IK joint weight alone. That's just undisturbed. Okay. So got those connected. I'll just press 1 again to hide that or collapse that again. So the other way that I usually prefer doing it when I have multiple objects like this is I'll go to Windows, General Editor, Connection Editor. Okay. And I have to load in basically my output. So it says right here, this is my output. So this is what I want to connect from, and then what I want to connect to over on the right side. So from, I select my transform control, and I do this reload left. So that puts my transform control over here. And same idea, these are all the attributes I can connect from. I think I've changed this under options, attribute order. I think it's set to, well, I think it's set to default by default. It is set to default by default, which is kind of similar to what we saw here. The order is a little bit different, but your custom attributes are always going to be down at the bottom. Usually I prefer having my attribute order set to alphabetical, so I actually can find it. Otherwise, it's kind of random where things are placed. So there's my left arm IKFK attribute right there. You may also, I guess this is kind of another reason people may not like the connection editor, but under left display or right display, we also have a couple of checkboxes down here at the bottom. I have non-keyable set to on right now, which shows me all kinds of other attributes that I can connect from. If I turn that off, it pretty much cleans it up to just your transformation values and any custom attributes you have in there. So I turn that off and on all the time, depending on what I'm connecting. But for what we're doing right now, this is going to be a lot easier to visualize the attributes we're working with. So same thing now, let's grab a constraint and we're going to reload that here on the right side. And you can do the same thing here, right? If you want to show non-keyable, you're going to see a lot of other attributes, but in this case, I don't need it. So I'm going to turn that off. And here are my weight values. So I will click on the attribute I want to connect from, which is my left arm IKFK. And then I'll click on the attribute I want to connect to. Okay, they'll both be highlighted in blue. It'll draw the wire here in the node editor. You can look in the channel box and verify that it's working. And everything's all hunky-dory. Okay. I understand that that looks a little bit more complicated and harder than what I did before by just dragging and dropping wires. But one of the advantages here is I can select multiple nodes and I can load them all up at the same time here in the connection editor. And I can select the one attribute I want to connect from, and then I can select multiple attributes that I'm connecting to really fast. So I just selected, for all three of those, I just selected weight 0, which is our FK. Right, and you can see I connected those up really easily. So it's up to you. I bounce back and forth. I mostly use the connection editor, just FYI. And if it ever doesn't make sense, then just stop me. But it's doing the exact same thing in the connection editor as it does here in the node editor when you drag a wire from an output into an input. Okay. So great. We've got for the left arm, all of our FK weights for our constraints are now tied into our IK FK switch. Okay, we've done that for all of the parents and all the scale constraints. So we're halfway there. Now we need to get this IK section all worked out. So, and I mentioned here we have to add this reverse node. So to do that, just here in our node editor, you can just click Tab and just start typing in the node you want. So we're doing a reverse node. We'll just click on it and it'll create it. Okay. If you haven't spent a lot of time exploring the node editor, you might be kind of intimidated because you're like, I don't know what the nodes are called. I don't want to have to type in there and remember it all the time. At the far left of the node editor, there's this little plus icon on whatever that is. It looks like a computer laying on its side to me, but I don't know what it is. If you click that, it brings up this create menu, and you'll find all of the utility nodes that exist in Maya. You'll find them here in this list somewhere. So if I looked really closely, I'd be able to find this reverse node somewhere. But I don't want to look for it because it takes too long. There's a filter here. But again, you have to know the name of it. But just click that and it'll create another reverse node. So just know that it's there. In case you can't remember what a node is called, you can go and look through it there. All right, so I've got this reverse node. Again, all a reverse node does is take an input and then say 1 minus input, and then it'll spit the answer out as an output to this node. Let's give it a name. I'm just going to click here on the name, and we'll just call this left arm IKFK reverse. Usually use 3 letters. Going to be kind of an intermediary, just like we drew up in the whiteboard here. Okay, so let's go ahead and expand this a little bit. And under inputs, you can see it allows you to put in up to 3 values. Okay, and each of these values, it'll say 1 minus input X, 1 minus input Y, 1 minus input Z, and then it'll spit them out in their respective channels as well. We're only doing this with one value. We're just going to put it in as our X. It'll do its equation, and then we're going to take the output X with the answer. So again, we're taking the value of left arm IKFK. We're feeding this in to input X. This magic math equation happens in the space between our green dots. Right, and then we're going to take our output X and we're going to connect that to our constraints. So let's come back here to our first constraint. This is our left arm 1 RK, right? And we're going to connect this output X into our IK weight. Okay, if we take a peek at our constraint now, you can see that we do have that yellow bar that indicates there are connections. We have IK is set to 1 and FK is set to 0. Okay, and that should, so if you look at that, that tells me that the IK system is on and the FK system is off. Okay, that should be the case if my IK FK switch, so the IK system is on, the FK system is off. That means my IK FK switch should be at 0. So we'll click on the transform and we'll verify it is at 0. Okay, if I slide this up to 1 now, look at the whiteboard, it should be the inverse now. FK should be on, IK should be off. So we'll click on the constraint, and indeed FK is on and IK is off. Okay, so this little utility node is doing exactly what it's supposed to. I just need to hook up the rest of these constraints now. So we'll click on that, press 1, and I'm going to use the connection editor for this because, again, I think it's a little bit faster when we have multiple connections. So I need to select the reverse node. Oh, let me show you this too. This is kind of a cool trick. If I have a node here, this is my output node. I want to connect from this to another node. I can hold Shift and middle click from the output node and drop it onto the input node. And it will automatically load those, bring up the connection editor and load them up into their respective sides of the connection editor. Okay. So this is one of those cases where my reverse on the left, I can't see my outputs. So I have to come here to left display and I have to show non-keyable. and then my outputs will come up. Okay, I can expand this. There's my output X that I want to connect from, and then on my scale constraint, here's my IK weight that I want to connect to. Right, and I did that there. So both the parent and the scale constraint for left arm 1 are set up correctly. So at this point, I'm just going to select the rest of these constraints for joint 2 and joint 3. I'm going to load those on the right side here. Output X is still the output I want to connect from. Then I'm just going to select my IK weight for each of these constraints. Connect them all up really quick. Okay. My wires are all created. I should click on any of these right now, and I should see that FK is on and IK is off. Okay, and that system is done. That's all set up. So you can verify it's working. Let's bring this node editor down a little bit so I can make my viewport bigger. And I'll just move my IK system. Okay, so you can see that nothing is happening with the RK. That's just staying locked to the FK system, right? And it should, because the IK-FK switch is set to 1. FK is on. If I were to move my FK system, we'll see that that green RK system follows. Okay. Now if we come in here and switch this down to 0, you see those RK joints transition and now match the IK system. So FK moves, nothing happens to the green joints to the RK system. But when I select the IK control, move that around, the RK follows. Okay, so that arm is working perfectly. One other thing we want to work out here is the visibility of our controls. Okay, if the IK system is on, I don't need to see the FK controls. Obviously, the other side of that is true as well. So using the node editor, I'm going to do the exact same thing, right? If my switch is set to 1, meaning my FK system is on, then I want the visibility of my controls to also be on at a value of 1. And I want my IK controls to be set to a value of 0. Okay, and the inverse is true for when this is set to 0 and the IK is on, and the FK should be off. So we can use these exact same values that we're tying into the weights. We can tie that into the visibility of our controls. So let's go find our arm controls. I'm just going to select one of the controls, press F. Okay, and we set up this group just for FK controls. And all I have to do is switch off the visibility of this group and the whole thing goes away. So again, really convenient. I'm just going to select my left arm FK controls and drag them in here. We've also got our left arm IK controls, and I'm going to drag those in here as well. Those are both here in my node editor. Goes down a little lower here. Okay, so FK controls, again, direct connection. Anything FK is a direct connection from this IK-FK switch. So let's expand this a little bit so I can see visibility. Oops, I can move this one. Okay, so FK IK switch is going to go directly into my FK group. And that's all I need there. Okay, and then my IK group for my controls, that's going to tie directly into that reverse node where that value gets flipped. So we'll just go to that output X, expand this so we can see visibility, and we're going to go output X to visibility of the IK controls. Okay, so we'll need to tie this into that little line we created too. In fact, let's just do it right now. If I go to my deformers group, pull vector line group, and I'll have to do this direct. I don't have a group set up. I can just do it directly onto the line itself. So left arm, I've got these orders funny. Left arm pull vector, let's just bring that down here as well. So there's my line right there. Those are just shape nodes. I don't need to see those. Right, and because this has to do with the IK system, then I have to tie it into that reverse node. So, well, I can't see my visibility right now. You can if this isn't expanded, by the way, you can drag it onto that white dot. and that will show you channels that you can connect it to. So we'll just go into visibility like that. You can see it disappeared. So the ARM or the IK-FK control is set to 1, which means FK is on, and that's what we see. When we switch it down to 0, you can see the FK turns off, and the IK systems turn on. Okay, so we've got those controls. Not only are the RK joints following properly, but the controls, necessary controls, are switching on and off as needed. You'll notice right there at a value of 0.5, it'll show both of them because it doesn't know if it should be on or off, but anything above 0.5 is considered on, anything below is considered off. Just so you know, that's how it's interpreting things. Okay, so let's just set that to 0. Actually, I'll leave it at 1. I'll do that every time I finish the system. I'll just leave it at 1 so we can very easily know which ones are finished and which ones aren't. Okay, so I'm just obviously going to go through this process 3 more times. But I'll pause there for a second and see if there are questions. Okay, am I over-explaining?
No, it's useful.
Okay.
It's all useful.
Okay, all right. Well, let's keep going then. If there's no questions, let's just carry on and do this 3 more times with all the other systems. So I need to still use the transform control, but the rest of these are specific to that limb. It's done. I'm done with that limb. So I'm going to select the rest of these nodes and remove them from the node editor here. And let's work our way to the right arm now. Okay, so let's find the right arm RK joints, which are right here. And we're going to grab all of their constraints. I'm just going to middle click, drag them here into the viewport. Okay, we'll just start with those. Let's just create a reverse node right now. So again, I type tab and then reverse. I forgot to bring up that keyboard for you guys. I don't know if that's helpful for everybody, but some people have said it's helpful, so I'm going to bring it up. Pardon me?
It's very nice.
Okay. Sorry I wasn't there earlier. And that I still haven't figured out how to get a middle mouse button on this dialog. But okay. So there's our reverse node, and we'll just call this right arm IKFK reverse. All right. Expand this a little bit so we can see our inputs. Let's just pull this in right now, our attribute. So we have this node ready to go. So that's the right arm IKFK. And we're going to pull that in as our input X value. Okay. So I'm going to pull up the connection editor again because I just think it's easier with all of these constraints. So I'm shift middle clicking from the transform control to one of these parent constraints. Doesn't matter which one right now. And then I'll just select all of the parent constraints and reload right. So that will load them all up here on the right side. And my transform controls on the left. So I'm just going to start with all of the FK stuff. So if I find right arm, there it is, IKFK. And that's going to be connected into the FK weights for every one of these constraints. So there's an FK weight, there's an FK weight, there's another one, another one, another one, and there's the last one. So there's 6 of them. And I should see the respective wires all hooked up. 1, 2, 3, 4, 5, 6. They're all there. Okay. And then we just need to do the same thing with the IK system. So now I'm going to be using the reverse node for IK rather than the transform control. So we'll select the reverse node, reload on the left. We're using the output X. Remember the IKFK switch is fed into the input, and then the output gives me that inverted value. So output X, and here we're just going to connect to all of our IK weights. IK, 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 IK. Okay, so the joints are good. That's all good. So now we just need to hook up our controls. So let's pull in the right arm line. We know that's going to be hooked to our IK reverse node. So is our right arm IK control group, main control group. And then we can get our left arm control group here. Right there, that's going to be hooked directly into the IK-FK switch. So we'll just do these here since we only have a single one to do. So right arm IK-FK, drag that into the visibility. Okay, collect that. And then both of these, again, press 3 to expand them. These are both going to be tied into the output X of the reverse node. So visibility and visibility. Close this. Pull this down again. So right now my value is set to 0, which means my IK system should be on. Verify it's working, and it is. My IK controls are all turned on. FK controls are all hidden. Okay, let's go ahead and make the switch here. Go to 1. The RK system is going to meet up with the FK. IK controls disappeared. FK controls appeared. And we're good to go there. Okay. You notice the hand is following the FK system, by the way. That's one of those things we said we were going to come back and fix. We need that to follow RK, not IK or FK independently. It needs to follow the RK system. So we are going to come back and fix that. Okay, so that's working great. So I'm just going to undo until everything's back at its default state. And we'll set right arm IK-FK to 1 again, just so we know we did it. Okay, work our way down to the leg. So we can go ahead and remove everything from the node editor other than the transform. And then let's load up our RK system constraints again. So there's left leg. There's the RK system. There's all of my constraints. While I'm here, I think I'll just load in all of my control things as well. So here's my left leg pull vector line. Here's my left leg control group. And here is my right leg FK control group. Stick that over there. Okay, so I have everything here that I need. So let's just create our reverse node. So tab, reverse. This will be left leg IK FK reverse. Let's go ahead and connect this up to the IK-FK switch. So there's left leg to input X. Okay, and let's work on our constraints first. So I'm going to shift middle click drag from the transform to one of these constraints. And then I'll just select all of the constraints again and reload right. And I need to find my switch here, left leg. Here it is, left leg IK-FK. And that goes directly into my FK joints. So there should be 6 of those, 4, 5, and 6. Okay, and then we can connect my reverse node up to all the IK weights. So we'll load that on the left. Output X, IK. Okay, those are all set up. And heck, I'll just use the connection editor for this. So there's my FK control group. So that's going to be hooked up directly to the transform. So I need to reload the transform on the left side. There's left leg IK-FK, hook that up to visibility. And then my reverse node is going to be hooked up to that pull vector line and also the IK control group. So reload the reverse node on the left, and then I can select the curve and the IK group. And we'll just connect the output to the visibility there. Oops, I grabbed the shape. There we go, and the visibility there. All right, so it's connected to this and this. So again, verify it's working. So right now I'm set to 0, so the IK system should be on. We see just the IK controls right now. for the leg, ignore the foot. Okay. And that's not working right because I'm on the wrong leg. And I messed up, didn't I? I grabbed the right leg control group here for the FK system. I need to delete that connection, so I can just select this wire, press delete. Let's make that group visible again. It should have been the left leg. So let's remove that. There's the left leg FK group. Yep. Okay, and expand it, pressing 3, and we'll go from left leg into visibility. There we go. Thought something was funny there. Okay, so you can see the green RK system is following IK, and I only have my leg IK controls on. We'll flip the switch to 1. FK controls turned on, IK controls turned off, and the RK system is now following the FK leg. So everything looks right there as well. We'll just undo back to our default state. And turn this on to 1. So we know it's finished. Okay, and let's tie up the left leg. We do still have to do the foot. We have an IK and an FK foot. Did we create IK and FK in the foot? We did, right? Yeah, we don't have a full control structure there yet, so set up the constraints. We did not, I didn't teach you guys the reverse foot last time, right? IK reverse foot, does that sound familiar?
No, you did not.
Good. So we're going to do that this time. Okay. So where are we? Right leg now. So again, I'm going to remove all of these nodes that I no longer need. And now we're working specifically on the right leg. So let's go and find all of the constraints for the RK. Middle click and drag them into the node editor. And then we'll also grab the FK control group, which is here. And we'll grab the IK control group and the pull vector line. I really only need that guy. Okay. So one more time. Create a reverse node. The name, right? Leg, IK, FK, reverse. Let's expand that, pressing 3. And let's take our right leg IK, FK switch and plug that into input X. So that is ready to be connected. Shift middle click drag from transform control to one of these parent constraints to bring up the connection editor. Select all of the other constraints here and reload them on the right side. And then we're going to connect all of the FK attributes for the right leg IK FK control. Sorry, we're going to connect this attribute to all of the FK weights. So right leg IK FK, there are my weights, 6 of those. Okay, and then we're going to connect all of the IK weights to this reverse node. So with the reverse node selected, I will reload left, output X. Okay, and we're going to all of these IK weights. Okay, while we're here, let's just hook up the IK visibility of the controls in the line. Those are hooked directly into the reverse node. So let's just select these 2 nodes, reload them on the right, and we're going to connect their visibility directly to output X. And then our FK control group is going to be tied directly into our transform control, to the IK FK switch there. So again, I just did a shift middle click to load them both into the connection editor. And I'll just find right leg IK FK and connect that to the visibility of the FK control group. Okay, and again, let's just verify this is working. So RK is following the IK system. Let's flip the switch to 1. RK does what it's supposed to follow the FK, right? And the IK controls turned off, FK controls turned on. So that's all working. So we'll take that back to its default state. Before I started moving things around, set that to 1. All of those systems are hooked up now. Okay. The foot, like I said, is a little bit different. Let's save this really quick so I don't lose anything. We are going to build on the concept of the IK foot. So you do have 2 different feet or foot systems, whereas before we did something similar to the hand where you only had an FK foot. So we'll have to spend a little more time on those later, but we still need to hook them up. So the IK-FK switch for the leg is going to include the hip, knee, ankle, and it's also going to include all of the joints within the foot as well. Those systems will switch on and off at the same time. So we just need to expand what we've already done and tie it into the foot as well. So we already created the feet joints, and we created controls for the FK portion of it. We haven't done that for the IK portion yet, but that's okay. We will get to that. But we're still going to create the same switch functionality. So we need to create our constraints. So we're going to go FK, IK, and RK for joint 1. Same thing we did before. We're going to bring up the rigging menu, constrain, and we're going to create parent and scale constraints. Joint 2, same thing. Press G. Oh no, that's not going to work. That only does one of them. Parent scale. Joint 3, parent and scale. Okay, do the same thing in the right foot. So there's joint 1, parent scale, joint 2, parent scale, and joint 3, parent and scale. And that made a mess of my node editor. Fantastic. Okay. So let's just go ahead and hook up what we can. We don't have IK controls in there yet, so we won't be able to hide those. We'll have to come back and do that later, but we can hook everything else up, the same as we did with the leg. So let's just get rid of everything other than the transform node. Oh, you know what? I also could have kept the reverse node. So let's talk about how we can find that. I want to bring that reverse node back. We're using the same one for the leg. I'm not going to create a separate reverse node for the foot because it's the same switch. Okay, so how do we bring that back? If you know the name of it, right up here at the top, right? I think this is set to this absolute transform node mode by default. You can click on that grid here and do select by name. If you know the name of it, which we should, left leg IK FK reverse, and it selects that node for me, and then I could add it like this to the graph. Okay, that's one way I could find it. Another way I could find it is by graphing the inputs and outputs of the transform control. I've already connected this control up to a reverse node as one of my outputs. So if you remember these boxes with arrows next to them, this graphs everything coming into the selected node. This graphs everything coming into and out of, and this one just graphs everything going out of. So I just need what's going out. I need my outputs. So click on that, and that's going to graph all of the stuff that we just connected. There's all the constraints, all the controls, everything. But in there, look, there's all of my reverse nodes. So I need the left leg. That's right there. So I think what I'll do.
Spaghetti.
So yeah, it is, seriously. That's one other way I can do it. And then let me show you one more way, because that can get really messy. You could have hundreds of nodes in here. It's really hard to find it. One other way you might find it is if I bring up the hypergraph. A reverse node is called a utility node. Okay, it's not a material. It's not a texture, but here under utilities, I can find those nodes that I created. A reverse node is a utility. So here are my 4 reverse nodes that I created. So that's one other way that you can find them, okay? And just so you know, this essentially is the node editor down here. So I could work within the hypershade just the same as I'm working out here in the node editor. So we'll close that out. So what I'm going to do here is I have the left leg. Let's just select the left leg and the right leg while I'm here, and then I don't have to go searching for it again. So left leg reverse, right leg reverse, transform control. I'm going to clear out the node editor. So here's my little sparkly cleans. Clear it all out, and then I'll just reload my selection. So that'll bring back the transform and those 2 reverse nodes I had selected. And that brings back the shape. I don't need that. Let's just remove that as well. Okay. So let's focus on the left leg first. I'll kind of tuck this over here so it doesn't get in the way. So we've got the foot here. So let's get all of our constraints on the RK system. Bring those out here. And our foot controls on the RK system that we have in place right now. Let's take a peek at those as well. I need to grab their control group and drag that in here. Okay, like I said, we don't have IK controls right now. We'll have to come and set up their visibility later. We'll also have to hook them into the IK joint so they do what they're supposed to. Okay, so let's just hook this up the same way, right? I'm going to middle click, shift middle click, transform to the constraints, and I'll just select all of my constraints and reload them on the right. And I'm looking for left leg IK FK, and here we're going into all of my FK weights. And you know what, while I'm here, wait, that's not the same control. I grabbed the leg controls. I should have grabbed the foot controls here. There's my foot control group. Let's just load that here on the right as well, and we'll just click on visibility for the feet controls. Okay, then we can load up the reverse node on the left and all of our constraints again on the right. We've got our inputs already set up, right? We already set this up for the leg, so I just need to grab the output, and we're going to connect that with all of our IK weights now. Okay, and that's all I can do because I don't have the IK foot controls in place, so that's what it is for now. So let's go ahead and hide everything here that has to do with, or sorry, not hide, but remove it from our node editor. Everything that has to do with the left leg and the foot. And let's go now to our right leg and foot. So now we can select all of the constraints on our right foot RK system. Bring those in. Okay, here's my right leg reverse is already in place. Let's get the right foot control group for the RK system. I'm sorry, for the FK system on the right foot. Sorry, those are really small. I hope you guys are able to see them okay. Okay, middle click drag from the transform to one of these constraints, and then select all of the constraints and reload them on the right. And we're going to connect from the right leg IK FK to the FK attributes. Remember, that's always a direct connection from our switch to the FK attributes. And let's go from the reverse node first this time. Again, this reverse node is for the leg. We already have that attribute hooked up correctly for the input. So we're just going to take output X and connect that up to all of our IK attributes. Okay, that's all of those. And then again, visibility on our right foot FK group. So this one's going to be a little harder to verify that it's working. I don't think we hooked the foot up to the system either. Oh, we did. Okay, that's good. Oh, maybe not. That's my FK joint chain. Let's, we need to show our other joint chains to verify what's working and what isn't. So let's show all of these. And all of this so I can quickly set their radius as well. So all of my FK joints I set to a radius of 1. That's right. FK set to a radius 1, IK set to a radius of 1.5, and RK is set to a radius of 2. I can do their colors in a second too. So FK is 1, IK is 1.5, RK is 2. Okay. And then we'll just go to the first foot joint, bring up the attribute editor. This is the FK joint. And I need to go to display, drawing overrides. Override, we're going to set that to that blue color. The IK, same thing, but we're going to set this to the red. Where are you, red? There it is. And the RK, we're going to set to that green color right there. Okay, same thing for the other foot. FK is blue. IK is red. There it is. And RK is green. See our 3 different joint chains. So we should have the FK moving around. I can't remember. Yeah, so the RK should follow the foot because we do have that hooked up properly. Okay, that's good. That helps us to verify everything. And then as we switch between the IK and the FK on this foot, so there's left leg, right? The leg and the foot goes to meet up where the IK is, right? Our foot isn't hooked up, so this still verifies it's right because the foot disconnects, the RK foot disconnects. So looks like we're good there. Let's go check the other side. Rotate this back. The RK is following. The FK controls are on as I switch this. Right leg. Right. FK controls go away. The foot goes into its correct place. Stays there because we don't have that foot hooked into the IK system. All good. And I hope not to create confusion there. The fact that we don't have an IK system in there yet for the foot. I know usually we have the systems done first and then we hook up all the constraints. But if you have the joints in place already and you want to tie them together to the RK system and then build the rest of our system later or add to it or revise it later on the IK side of things or the FK side of things, you can. It's not a big deal. They're just tied together already. We just created those connections on the front side instead of the back side. Okay. So let's go ahead. I'm just going to save this again. Don't lose anything. And stop there for a second. And see if there's any questions. You guys feel comfortable with this? You can replicate this?
Feeling good.
Yeah.
As long as I have the video, I can do it.
Okay.
What did you say what was useful about the reverse for the foot? Or did you not mention?
I don't know if I did yet. The advantage of it is basically we're going to create a system that will allow you to, for example, roll the foot from the ball, if that makes sense. And the leg at the ankle will move with it. So the knee will bend, the hip will rotate, the ankle will rotate, and all of that based on a motion from the ball of the foot or from the toe or from the ankle. And the whole rest of the leg will interpolate, or I guess the values will solve appropriately based on the movement of the foot. Because right now, you've got the ability to just move the foot, right? And the leg kind of does what it needs to, but this way it allows you some increased movement within the foot that the leg will respond to. You can still lock the foot in place. So yeah, you think of like a walk cycle, right? You can still lock the foot in place. You can use this control when you're ready to go into your up movement in the walk cycle and roll up on the toe. And your leg, everything in the leg will do what it needs to in order to allow that rolling to happen on the foot. So you don't have to go in and reverse animate a bunch of other things. Okay, let's take a quick breather. Take a quick walk. I'll see you back here in 5 minutes, okay?
Thank you.
You bet.
Thank you.
Okay. Hopefully we're mostly back here. Okay, so let's tie up a couple things here. We're pretty close. Any questions, by the way, while we took a break? Something come to mind? Okay. Then let's kind of move on and tie a few things up. First of all, I really don't need to see these other joint chains anymore. I only need to see the RK system. So let's just go into our outliner and hide our other systems. So, okay. I'm just selecting the root node of each and just hiding it.
Now, didn't you set something up last time where it automatically hid the joints when you switched between IK and FK?
I mean, you could, I mean, just like we did with the controllers, you could do that with the joints if you want, but really we should never see the FK or the IK joints again. They're just there as that utility to drive the RK system. So once we know they're working, you can hide them. We never have to see them again.
Oh, okay.
Yeah.
Good to know.
Yep. Okay. And I mean, yeah, to just, again, kind of visualize the point, right? My FK system is on right now. And I'm only showing the RK system. As I blend now, you'll just see the RK system goes where it needs to go. The IK system turns on. And really, we only see that one joint system. So it removes a lot of the clutter from our scene. You did see there, though, that the hand detached, right? So let's fix that right now. If we go to the hand constraint, or the hand group, and look at the constraint. So right now on this hand control, we have a parent constraint to the left arm FK control, right? So we constrain directly to this guy. Okay. Like I said before, the hand isn't going to be tied directly to the FK or to the IK system. It should be connected to both. So and the RK system is the interpretation of both, one or the other, right? So really we're going to hook this hand directly to our RK system so that it will follow whichever one is turned on. So I'm going to delete the constraints here on the hand control, and I'm going to select the RK joint, the arm. So this is left arm left arm 03 RK joint. Okay, and I'm going to constrain our hand control directly to that joint. And we will do both a parent and a scale constraint. And, you know, we don't often constrain directly to joints. It is okay to do so. We just often don't do it because we're constraining to other controls. But again, you just think of the RK system that's the interpretation of the FK or the IK system. And that's where you're following. So we're going to constrain directly to that end joint there. And now just to verify it's working, I should be able to rotate my FK arm. Then we'll flip this switch to 0. You can see the hand is going back where it's supposed to, following the arm, moving around with the IK system. Okay, if you guys remember early on when we were creating the IK system, we put an orient constraint from this IK control to the last joint, to that wrist joint in the IK system. And the whole reason for that is now if I rotate this control, I'm able to rotate that last joint, which in turn will rotate the hand control, the parent group, which allows me to actually rotate the wrist using this control, which is helpful when you want to do things like even just bring the arm in like this. You may not think about it, but that wrist is rotating. As the elbow bends like that, the wrist is rotating. If we didn't have that orient constraint on there, then your hand would rotate to stay in line with your forearm. So I remember someone saying, well, why are we doing this? And that is why, so that we can keep the orientation of the hand control locked to the orientation of the IK control. Okay. So that hand is done. It's ready to go. So let's flip over to the other side here. The hand control. Delete the constraints that are there. Then we just need to find the RK joint chain. There it is for the arm. So we'll select that last joint, 03. That's the wrist. And we're going to parent constrain the hand control group with, or parent and scale constrain the right hand control group. Can again verify it works. That works. We'll switch over to the IK. Right, moves where it should. Oh, look, there's the issue right there. I did not put an orient constraint on that last IK joint. So see how the hand, here, let's look at them together. So see how the hand stays in alignment with the forearm. And here, it stays in alignment with that control. Okay, this behavior is so much easier to animate. So I just need to go in and fix that. Okay, I just have that one small little issue. So to do that, I'm selecting my IK control. I need to go in and find my right arm IK joints. Okay, and I just need to put a constraint on that last IK joint. So I'm selecting the IK control, the joint there, and I'm going to do an orient constraint. Okay, now you can see that the rotation of that joint respects the IK control. Okay, so we'll go back to there. I believe if I've switched these back to FK, I've still got my FK controls have been rotated a little bit, so I need to make sure I reset those back to their default state. All right, and as I switch back and forth, you shouldn't see any rotation or jumping or moving in the joints when everything's at its default state. If you do, you've got problems. Could be any number of things, but it usually comes down to orientation issues. Okay, so those are good. I'm just going to leave those at 0 now. Leave it as IK at the default state. Okay. And let's do the same thing down here with the feet. So actually, no, we can't do this yet. We have to tie the feet together with the reverse foot. So the FK is following as it should. So we'll have to come back later and tie the IK foot on. So right now it just doesn't work. The IK side just doesn't work properly as far as the foot's concerned. But the hands are functioning properly. And we'll save it again. What time we got? 4:30. So I think next time we'll talk about hooking these systems together so that we have an entire body, and we'll also build our reverse foot. So between then and now, I think the next step we can do is hooking up our proxy geometry. I'm just going to close out my node editor. Collapse all of these things, and here's my proxy geometry. I didn't finish naming mine. I'll still need to do that, but you guys should have done that. So what I'll have you do is you start hooking your proxy geo up. So for your spine, that's easy. We only have these single joints here. We don't have any crazy systems going through them. So you're just going to select the joint and the associated geometry. I haven't split those up. Let me just separate those really quick. Separate. Okay, so I would constrain these two, right? So joint and then the geo, and we'll just say parent scale. Work my way up. Parent scale. That tip joint. Upper torso area, parent scale. We'll work our way down the arms. So parent scale. Parent scale. You guys get the idea. You're just going to go through to every one of the joints that has an associated piece of geo and you're going to hook it up. Okay, so when you're done, you should have a character that you can start kind of moving around. I realize like your spine right now is going to be broken, right? Because we don't have the arm connected to the torso. But other than that, you should be able to get an entire character that moves. Let me say that differently. That's not even true. You should be able to tie all of the geometry to a joint, and there are systems there at this point that you can move around independently the different parts of the body. We'll tie it all together next time.
You got what you meant.
Thanks. Okay. I'm gonna do that.
Yes, sir.
I've got to fix that here on my end. Okay. So, you know, as always, if you were doing it alongside me, great. Otherwise, make sure you go back and get it up to this point, and then get all of your geometry constrained to the respective joints. Okay. Again, I think I said this, and it's probably clear. But anywhere where we have these IK and FK systems, you're constraining to the RK joint. Not to the IK, not to the FK, just to the RK. Anywhere where we don't have that, like in the hands, you're just constraining directly to the only joints that are there. Okay. So it's pretty much arms, legs, feet. The feet right now, I know we're kind of not finished there, but you're going to constrain those to the RK system. Okay. If we've got multiples, it's always to the RK system, not to the others. Why does it look like one of those joints didn't scale like it was supposed to? FK. There we go. Now I can see them better. Okay. So that's where we are. And then next time, like I said, we'll try to get the rest of the rig connected, do your IK feet. IK reverse feet. And then this guy, other than skinning, I think we're almost done. Okay?
Appears to be so. Yes.
Yes, we're close. And then I'm going to set you loose on your own character, well, a different character, and you'll do the whole thing. Whee! Yay! Okay? Any questions?
Not at the moment.
Okay. Anyone else? Is anyone using Marmoset toolback? Oh, go ahead.
Oh, never mind. I thought somebody had a question in the comments.
Oh, okay.
What about Marmoset?
I was just going to say, is anyone using Marmoset toolback?
No, but it looks dope. It's just expensive AF.
It is quite expensive, but it's so cool. They just instituted ray tracing in the latest version, and it's.
Do we have any kind of student access, or is there any way that we could get student access?
We've talked about getting it. I don't know where that conversation's gone. I'm going to follow up on it. I think it's worth you guys learning.
Well,
I think
if not,
they usually have deals every year.
They do around like Black Friday, and it's still expensive, but
it's still super expensive. I do want it though. I want to buy it.
So cool.
It's like a substance kind of replacement.
They've just instituted the ability to do texturing inside of Substance. Yeah. You can do your lighting, you can do you can apply all your textures as well. But one of the other cool things is you have access to transformations as well. So if you need to move something in your scene, you can set up animations. You can, the baking in here is actually, I think, is better and better. You can control what's happening a lot better and like paint things in or out than in Substance. It's not a replacement necessarily for Substance. The actual texturing tools aren't nearly as powerful as what you find in Substance. But given time, they may get there. That's pretty cool.
Yeah. For like displaying sculpts from ZBrush and like doing like really intent portfolio renders and things like that.
Mm-hmm. Yeah, that's right. I mean, check out these renders.
Beautiful. That looks real.
Doesn't it?
Wow.
And that's using their new ray tracing. It's just so gorgeous. And it's not, when you turn ray tracing on, it's not real time. It does take a little bit more time to render these things out.
Right, yeah.
So it's a normal path tracer, not like a real time?
So when you turn on ray tracing, yes. When that's not on, it is.
That's what it looks like. It looks like Redshift or something.
Yeah, it kind of is. That's all GPU based. So I've been kind of experimenting with this same idea here with glass vials and liquids on the inside, and they render out fairly quickly for as intensive as that is. Light bouncing through layered glass, through liquids.
Oof.
It's really impressive.
You got to bump those samples up though to get a clean render like that.
But you don't have to bounce them up that high. That's the crazy thing. And it's got a denoiser built into it as well. So even if your samples aren't super high, it does a really good job of just kind of smearing pixels together in a way where you're not losing a lot of contrast. So even look below these glasses, you see the caustics that are underneath them, under the glass.
Man,
Just reflections.
that's so nice.
It's gorgeous. So anyway,
really pretty.
I've been playing around with that a lot. It's fun. I'll find out though. We had talked about it. It's something that I feel strongly that would be great to have. We'll see.
I mean, yeah, I would love it too, because then if we could get it by senior year, then portfolio renders would look clean.
Yeah.
So
yeah, absolutely.
I'm a fan. So
cool. Right on. Okay, guys. Well, I'll let you go then. Hit me up if you need anything.
Thank you, Clayton.
You bet. Have a great weekend. Get your rigs up to snuff with where we are. You got a few days if you need them.
They will be snuffed.
Tie them up next week. You bet. Thanks a lot, guys.
Sweet. Bye.
Bye.
Have a good one. Bye.